Okay. Thank you again, everyone, for joining us. We will start. So this webinar is about thermodynamic solar, and we have some distinguished speakers here who will present some real case studies from the world. So this project is mainly led by our member, Energy. So Hugo will present some points. So before we start the webinar, I'll go through some introductory slides about the Clean Energy Business Council, the CEBC. So CEBC, we are not for-profit membership organization based out of the UAE, but we cover also the Middle East and North Africa region, MENA. What we do is we cover specific topics, which you can see on the screen: energy efficiency, future mobility, specifically electric mobility, climate finance, green hydrogen, energy storage, as well as encouraging women to get into the clean energy sector. So the activities we perform throughout the year is mainly advocacy and thought leadership. We work very closely with the governments in the MENA region to try to accelerate the maturity of the policy and the different topics I just presented. We also have our own research, which enables us to publish reports, white papers, policy papers, and case studies throughout the year. You can find any of all of our publications available for free on the CEBC website. If you go to the cebc.mena.com and also you go to the Knowledge Center, you should be able to find all of our publications. We organize a lot of events, mostly in person, but now due to COVID, we have been doing a lot of webinars, which would give us this platform to share with people from outside the region as well. This is one webinar of this series of webinars. We'll continue to do this webinar, so please, if you don't have access to our newsletter, just go to the CBC website and subscribe, so you'll be able to get notifications when there's a webinar happening. We also have strong partnerships with other local, regional, and international organizations, and that enables us to provide wider benefits for our members. So you can see here, this is a sample of our active members within the region, covering different sectors within the clean energy. And this is a sample of our partners as well. As you can see, there are some international, some regional and local organizations from the MENA region as well. We work closely with them, organizing different activities, events, and publications as well. So that was a very quick brief about the CEBC. If you have any questions, please feel free to get in touch with me at any time. And just a few housekeeping notes before I give the floor to Hugo. This webinar, automatically all the attendees are on mute. So if you have any questions, you please feel free to ask those through the questions pane, which you'll find it on the right-hand side of your platform. If you're using your desktop, if you're using the phone, it should be in the bottom. So we'll be trying to answer as many questions as we can at the end of the webinar. So please make sure to put your questions there. After the webinar is recorded. So and the recording will be shared with all the attendees after the webinar by 1 day or 2. So please, no need to like take so many notes. You will be provided with the recording and also the slides of the this slide, and also the slides that we will be presenting will be shared after the webinar. So again, if you have any questions about the CEBC membership or anything, just feel free to get in touch with me. And with that, I'll give the floor to Hugo, who will give a 20-minute presentation. Then after Hugo, there will be a panel discussion with the other speakers moderated by Hugo as well. So with that, I give you the floor, Hugo, and also the screen sharing. Over to you.
Thank you, Ahmed. Let me just, I hope you can see my screen properly.
Yes, all good, perfect.
Thank you, Ahmed, and thank you, CBC, for organizing this event. I will be talking today about retrofitting hot water in hospitality, the thermodynamic solar option. After my presentation, I will introduce our guests, Gopa Kumar from Radisson Data Creek, Yasser from Radisson Fujairah, and Mohammed from Anantara de Palma. As you know, hot water is an important feature in hospitality. Actually, it's a crucial feature because it impacts directly on the comfort of the guests. So hot water is needed for the bathrooms, for the washrooms, for the kitchen, and for the laundry when applicable. And any issue on the hot water, being not enough hot water, pressure problems, or too much time in coming, it will generate inconvenience and complaints. Even more important, it can generate bacteria if the temperature is not met properly. All the water in the circuit has to be more than 50 degrees in the last point. And to give you an idea of the importance of hot water, it normally stands for 20% of total water consumption in a hospitality property. So normally, to produce this water, the traditional heat sources are used. I mean, electrical heaters or calorifiers, boilers, being diesel, LPG, SNG, or natural gas. And these technologies are used because they can give, on the design stage, enough thermal power to achieve the hot water demand at the same time the temperature that is required. So why retrofit? So you know that the design stage is done prior the hotel to open, and then the operator will come to explore the property, and the engineering team will do their best then to optimize the operations, to reduce the operational costs, and to make energy efficiency initiatives. So if they have electrical heaters or calorifiers, then the problems are the following. First of all, is the electrical heating is the less efficient way of heating water in the world. So to give you an idea, a new heater, for each kilowatt that will consume, only 85% to 86% it will go to thermal load. There will be a heat transfer loss. And then every year, due, for example, for calcification of the heaters, the efficiency will drop every year. Then they have a very high operational cost. I will give the example as Dubai. We have 0.44 fills per kilowatt hour, which is one of the highest rates in the Gulf area, but still very, very far from Europe, for example. And it makes it to be around 15% electrical bill. Then there is high maintenance on the electrical heaters and a high replacement ratio. Normally heaters are replaced every 3 to 5 years. And finally, the electrical load. It can always be an issue even in design stage, because there's, for example, parts that have limited load, like the Palm Jumeirah. But when you are increasing, most of the times it's not possible, as there will not be any load available. On the boiler side, they are more efficient than electrical heaters, but still they have a low efficiency to produce hot water. They have a high operational cost, and more importantly, they are not as predictable or stable as electrical heaters in terms of the price. So it will vary according to the international markets. So what is real today might be completely different in 6 months' time. And finally, they have a very high carbon footprint that everyone is tackle. And the future, of course, it's not a traditional based technologies. Then we have the green corporate strategies and the CSR. So most of the top brands in hospitality, they have guidelines, and every operator should suggest and implement every year strategies to be more energy efficiency, and of course hot water is one of them. And finally, even the country has its own vision where they want to be in let's say 10 years time, actually 9 years time, and the renewable energies need to gain more weight on the total demand of the country. So alternatives, we normally think about renewable energies, and the first one that normally comes to mind is the solar thermal panels. So solar thermal panels, they have the advantage of a very low operational cost, and they have a very good performance. The disadvantage of them is that they have a space constraint. So they require a big, a large and vast area to be implemented. And as you know, space is a commodity. For example, in the big cities, the rooftops are completely constrained because of the HVAC systems. Ground floors will not be used due to the cost of the square meter in the ground floor. So that's why there is no hospitality property that is doing 100% of their demand using solar thermal panels. So normally they target 10, 20% at most. Then they have a limited operation. So this part of the world, we are actually very, very lucky to have 10 to 13 hours of sunlight per day, but the solar thermal panels cannot operate during night. So normally they require a backup, which typically is a traditional electrical heater. So again, the less efficient system to heat water. So the combination of the two of them really gets the efficiency of the overall solution down. Then they suffer during summertime from overheating. So as you know, extreme temperatures in this part of the planet, they make the solar panels to suffer a lot, especially damaging some of the parts of the panel, like rubbers. The liquid, the solar fluid, if it doesn't have, for example, glycol or other material to avoid to boil, it will start damaging from inside of the panels. And if it is a thermosiphon technology, the tank will be the first to suffer with that. Then they require median maintenance. For example, the solar fluid should be replaced, spare parts should be also properly maintained. Then they require to be cleaned. If they are not cleaned, they are not performing as well. And this is something that will bring additional costs into the property. And finally, they have a medium lifespan. This, of course, will vary according to the quality or the make of the product, but a solar panel will last from 5 to 12 years in good conditions. Then there is the option of the heat pumps. The heat pumps, they have a medium-low operational cost, so they consume more to operate than a solar thermal panel, and then they have a decent performance. I mean, they are less performant than solar thermal panels, but still, comparing with boilers, they have a higher COP. So the big advantage here is that it's a standalone system, so it can operate during day and night, and that's the big advantage comparing with solar thermal. The disadvantages is it requires a high maintenance, especially on the evaporator. In this part of the world, a lot of dust will accumulate on the evaporator part, has to be cleaned in a regular way. Also, the lifespan is low, so these units, especially the air to water heat pumps, due to the dust, but also due to the salty environment of the Gulf and the high humidity levels in summer, it will make the lifespan of the product to be lower. For example, a heat pump without any maintenance would last 3 years, up to, let's say, 9-10 years at most. Then it still requires a decent amount of load of energy to work, and it has a limitation of the outdoor temperature. So if in summer the outdoor temperature is higher, let's say 46, 48 degrees, the heat pumps will suffer. They will start doing cycles and restarting, consuming more, and not operating as well as they should. So the option that we bring you is the thermodynamic solar. Thermodynamic solar is actually a combination, it's a hybrid solution that combines the advantage of the solar thermal panels and the heat pumps together. So we produce hot water using the sun radiance and the heat of the elements, everything that we can take out of the environment to put on the water. So like that, we can provide more hot water using less storage capacity, less panels, less space, all days of the year, no matter if it's sunny, cloudy, dusty, or even during night. What we require to operate is that the outside temperature is more than 0 degrees. If it is, and of course in this part of the globe it's always more than 0, we can provide hot water at 60 degrees in a standalone system. So What are the advantages? First of all, we are highly performed. This means that we can produce at least 66% more hot water per panel than a top European-made solar thermal panel, and we have a better COP than any heat pump in the world. Then we don't overheat, so our panels can withstand 120 degrees. We are fully protected from corrosion, so we don't suffer as heat pumps and solar thermal panels, because our panels are made of anodized aluminum with a certified marine coating, so we are not vulnerable to corrosion. Then we don't need to clean the panels because we are not using the sunlight, we are using the sun radiance and the heat, and we tested in multiple projects. Then we don't do maintenance on the panels. We do maintenance on the refrigerant circuit and on the tanks by replacing, for example, the magnesium anodes. Then our game changer is actually the space that we use. We need 80% less space than the traditional solar. And why? Because we don't need to respect orientation or inclination as the traditional solar panels. So we can place it from 10 degrees to 90 degrees. We can face any orientation, if north, and then we can stack them 30 centimeters apart, and we can have multiple levels. We can have up to 4 levels. So we can put 16 panels where we normally would put only one, where there will be only space for one solar thermal panel. And then we can produce 66% more hot water per panel. So that's why we can retrofit full buildings like the ones you will see afterwards. Then we have a flexible installation. This means we can install in rooftops, in facades, in parkings, in ground floor, and even in basement with some conditions. Then we don't operate per demand. In this case, we are very similar to a heat pump. It means that we are not operating per sunlight. We can operate whenever there is demand. If there is demand at night, and often there is in a hospitality, we are operating. And finally, we have a low running cost. Actually, we are the cheapest way of producing hot water in this part of the globe, and we are 90 to 92% less expensive on the operational cost than electrical heaters, 80 to 85 comparing with boilers, 35 to 40 comparing with heat pumps and traditional solar because of the backup. So how does it work? This is a schematic for one of our modules. So inside our solar panels, we are not using water like the traditional panels. We are using refrigerant fluid. And why? Because we can get much more from the environment using a liquid that boils at minus 46.7 degrees rather than water that boils at plus 100 degrees. So the liquid will go in negative temperatures into the panel. It will evaporate using the sun radiance and the heat, comes out as vapor, being pulled by a compressor inside our solar block, which compresses up to 28 bars, rising the temperature up to 72 degrees. Then it goes into a main heat exchanger located on the output tank, where we do the main heat transfer. Then the remaining of the energy will go to a secondary heat exchange, so we can use in a more efficient way the energy available. Then the vapor will go back into the solar block, passing through an expansion valve that reduces pressure and temperature, and going back in a closed loop into the panels. You never have to refill it because you are not spending the gas, you're just transporting the energy. So we are passing from liquid to vapor and the other way around, and from low pressure to high pressure and the other way around. Then the cycle will go on until we meet the set point. Then the system stops exactly like an AC, and then it will restart on delta T that you can choose from. Then we have the hydraulic line, the cold water line, the hot water return line, the preheated line, and the supply line. Our biggest module can produce with 32 panels, 32 to 40 panels, one compressor, and can produce up to 15,000 liters of hot water per day with 2 peaks as per hospitality demand. Then if you require more demand, we just have to add systems to work in parallel and connect them into a main header. A very interesting feature of our system is our monitoring. So on our big systems, on our domestic hot water large volume systems, we have built-in monitoring system. And the idea of this monitoring system is transparency in 3 levels. So first of all, we want the clients to know that we are delivering what we promise. We don't base ourselves on data sheets. We base it on real information. So we want to show that we are committed with the numbers we promised in the beginning. Second, it allows us to tune better the system and allow a better energy efficiency measure. And finally, it allows us to detect any issues, to do a better maintenance and a better post-sales assistance to the property. So you have some screenshots here about the dashboard that we give to the property, so they can see, for example, the instant power, the daily, monthly, yearly consumption. Then they have the daily kilowatt hour consumption, the daily
Okay.
I think we lost Hugo, right?
Yeah, I think he lost the power.
Okay, so just let's just wait for a second, and
Yeah.
let's see if he's coming back. Just a second.
Yes.
Hugo, are you back? Hello, Hugo. We hear you and see you. You are good now. Please continue. Hugo, do you hear me? Hello, Hugo.
Hello? Yes, hi.
Yes.
Sorry,
Yes, please
I
go on.
momentarily lost connection.
No worries. Please
But
continue.
you can hear me now well?
Yes, very well.
Okay, I imagine you lost me when I was talking about the monitoring system, correct?
Yes.
Okay, perfect. So as I was saying, the monitoring system allows us to measure flows, temperatures, and energy consumption, and we can be more transparent to the clients and do a better service in terms of tuning, maintaining, and detecting any issues that will be there. So some references for you. This is the Radisson Blue Data Creek. I will not explain it in depth here because we have Gopakumar with us to explain it a little better. I will just give some insights of the property. This was actually the first 5-star property in Dubai, built in or commissioned in 1975. It was the Intercontinental, then converted to Radisson Blue Data Creek, with 288 rooms and 10 restaurants. Here we replaced a diesel boiler by installing 80 panels using only 20 square meters. We installed it like this because we actually wanted to use the collateral cooling. As you know, the thermodynamic cycle has two sides of it, the heating side and the cooling side. The heating side, which is our main target, is to produce hot water inside the tanks. But the cooling side happens on our panels, our evaporators, where negative temperature liquid is passing through the panels, creating ice formations. So here the panels are actually producing cooling 1 kilowatt per panel. So we had here 80 kilowatts to use. So by putting it in front of cooling towers, the cooling tower, when it pulls the air, it will cool down the air by passing through the panels and entering the cooling tower at a lower temperature, helping the chiller to be more efficient. So this symbiosis was really interesting and allow us even to to do more savings and allow us also to have a better payback for the client. Anyway, Gopakumar will explain after this presentation a little more about his property. So here we have Radisson Blu Fujairah, and this is a different property where you have multiple buildings and each building is centralized. So it's not as the previous installation when one point would serve all the property. Here you have 9 different buildings, bigger and smaller, that have different needs, and we need to target at each one of them. So you can see some of the installations that were done there in the different buildings. So this was commissioned in July 19. We replaced electrical heaters and the savings are near 90%. You can also see from the installations, we try to do it very clean and very neat. In case any guests would see it, they would find it interesting. Another property is the Anantara de Palm. Again, this one is completely different from the previous two, where you have individual installations. So each one of the villa needed to be retrofit, and also the blocks of villas. So also due to the architecture of the building, we have to be very careful where to put the panel so we wouldn't affect it so much. You can see some of the pictures. So Muhammad, also the area manager for Anantara, will be here also to discuss about this. We replace also electrical heaters on this property. The savings are around 87%. So then the first hospitality project we have done in UAE was Radisson Blu Yas Island in Abu Dhabi. You can see 120 panels in only 33 square meters. You can also see in summertime with temperatures outside more than 45 degrees, you can see the ice formation on the panels, on the inlet of the panels. They switch off synthetic natural gas boiler in May 2018, and they got their payback 2 years and 3 months afterwards. So it was last year. Then we did the Jumeirah Saadiyat Island Resort. Here we did something a little outside of the box. We installed the panels on the basement without any sun radiance, but to compensate the lack of radiance, we revert the exhaust of the laundry to give us enough heat, enough airflow and humidity to run the system. So instead of the wasted heat to go outside, we are absorbing it and putting it into the water. So here we replace a synthetic natural gas boiler as well. We have 200 panels and we are producing up to 75,000 liters of hot water per day. Then we have the Fairmont Ajman, commissioned in April last year. Also indoor units. Here we had to oversize the system in 15% in order to cope with the lack of radiance. We are absorbing the heat in the ramp of the basement. And we are putting it into the water. We replace a diesel boiler here, and we are using the collateral cooling to cool down the parking using the existing ducts in order to bring more comfort to the guests. Actually, just a small point on basement installations. The parkings normally they are more stable environments than outside. Although there is no sun radiance, you have a maximum of 40 degrees in summer and a minimum of 23 degrees in winter, which is actually much better than night conditions outside during winter times. So now a quick insight about the retrofit phases that we normally take care. Of course, the process is much more complex than this, but this is some points to take in consideration. So first of all, the first phase is the analysis and sizing. So we have to go and look for the infrastructure. What is there? How is it done? How the hot water is produced? How the circuits are working? Then you have to see where we can put the solar panels, where we can put the tanks, how we can connect it. Because in the end of the day, we don't want to change infrastructure. We can optimize it, we can improve it slightly, but if it's working properly, we should not change, especially in retrofit with the operational hotel. Then we need to have historical data. Unfortunately, normally in hospitality properties, there is no submeters for hot water. So we need to try to get as accurate as possible to understand the demand of the property. So we get all kind of historical data like total water consumption, total electrical consumption, or diesel consumption, or LPG consumption, occupancy levels in terms of rooms, in terms of guests. Okay, and we cross-check, we do some linear regression to try to understand exactly what the hotel needs to be as accurate as possible, and of course, working always with the engineering team. And that's the next point. It's extremely important to connect with the engineering team and work alongside them. Engineering team are probably the ones that know better how the system works, and they are a valuable partner throughout all the phases of the process, even later on maintenance, on post-sale assistance. And finally, we need to come up with a good value proposition. I mean, on the technical side, because we have to do exactly the demand that is needed from the property in winter conditions, full occupancy, but also in financial way, to make sense. And right now, an ROI bigger than 3 years doesn't make sense. The second phase is implementation and deployment. And here, of course, our equipments are top quality, but it's also important to see the quality of materials and accessories, because you can have the best equipment in the world, but if you are saving on the materials and the accessories, then you will create weak links on the circuit, and that in the end of the day will make you fail. Then we should have a very low impact on operation. These are live operations, and the guests should not feel anything at all about this. So we need to minimize that impact in terms of noise, in terms of work, in terms of taking the materials, logistics into the site, but also to avoid shutdowns, and when it's needed to do it at the proper timing in coordination with the engineering team. The guests should even be warned about that period, and to do it as fast and good as you can do it, so that impact will be really minimal. And finally, to enhance the energy efficiency and lifespan. So the product brings already so much value in terms of energy efficiency, but then you should improve the insulation that is there on the circuit. The system should be protected from the sun, because sun will destroy everything. You should use the collateral cooling if possible. It's not the main target. Any advantages that we can take out of it are beneficial. And finally, the hot water return should be optimized. Most of the times, the hot water return cycle is consuming too much energy. Finally, the operation and maintenance. So here we need to do a proper tuning on the commissioning and even after that, so the system is running at its full potential. And we can see that by connecting also our monitoring system. We can know exactly what is going on, what are the needs of the property, and how we can adjust it to be really perfect. The monitoring, as I said before, is extremely important for the operation of the system, and also for the property to feel comfortable and know exactly what is going on. Then the after-sales service, as you know, in hospitality, has to be fast and good. So again, the guests should not feel any problem, and the monitoring again helps us to detect problems, because before they are really problems, they are small issues. And finally, we always try to advise the properties to use this as a marketing tool. So what the properties are doing, they're actually saving money, but at the same time they are helping the environment, they are helping the planet, and more the guests are taking this into the consideration when they are doing a booking, for example. So here are some of our references, some of our projects that we have done in UAE. And now I wanted to introduce our guests. Gopa Kumar from Radisson Data, Yasser from Radisson Fujairah, and Mohammed Abdul Wahab from Anantara the Palm. So I will start by passing to Gopa Kumar. So hi Gopa, good afternoon. Thank you for for participating in this webinar.
Hi, Hugo. Thank you for calling me to participate in this. I think you are already done that. Hey?
The idea of
I can't hear you.
what was your needs and why you went for a retrofit, and finally your experience about the thermodynamic option in terms of installation and operation.
Yeah. As Hugo rightly mentioned, we are one of the first five-star property in this part of the world, and we were traditionally using the diesel-powered boiler, steam boiler for hot water system. So this is one of the things which we were looking into, converting LPG and things like that. But again, the risk and the safety aspect and all when we consider. We were not able to proceed with this the project what we initially intend. Then later on, we could come across that Hugo and his team stating that they already done some project in Abu Dhabi, and incidentally, it is one of our own project, our own hotel in Abu Dhabi. So we had interaction with the chief engineer over there, and they said that it's working perfectly. Then Hugo came to my property and we had did a survey all around. But again, space was one of the biggest constraints for me to install this panel. That was the biggest challenge I faced initially. We couldn't get an agreement that where to fix this panel. And finally, then I thought, okay, let's use this because this panels always produce almost zero temperature, which is almost literally like a freezing temperature. So I was thinking where to use this the energy which is otherwise wasted. So in that discussion, we decided let's put it up close to the cooling tower. So cooling tower will take the draft through this panel and bring down some energy consumption in the cooling tower where the heat transfer can be much better. So in that discussion, yes, we had some challenge to install this, and we need to put up a structure and things like that. And thanks to Hugo, I mean, he was willing to change his way of installation to suit my requirement. And finally, it has been installed, and it's working perfectly. Once we know this system is working perfectly, we ran both the system parallelly for a couple of days, and slowly we shut down the boiler part. The steam is completely removed, and the entire hotel starts working under this thermodynamic system. And we maintain 55 as our head temperature. Then return is we are getting almost about 50. So I didn't do any changes in our plumbing system. We maintain the same system. We brought this thermodynamic hot water system into the building and just connected directly into our plumbing system. That's how it started working. And it's been installed in 2019. And quite happy. Good saving. What initially we planned to have saving of around 70, if I'm not mistaken, I think 72 or 74. Very, very conservative way we started. Then it's move on. And we got up to almost about 80% saving in that because the diesel price fluctuates, the savings differs as well. And once I came to know that this is a good system, then what I started connecting into my laundry, which is we do cleaning of, washing of almost about 3 to 4 tons per day, especially during 2019, not during the pandemic time. But then that was started by this system, there the temperature was maintained. Then all my restaurants have been connected. We have almost 15 outlets, including bars and all. So all the outlets have been connected. It's been on our outlets in a different building. Still, we could run it across because we use the same plumbing system. the overall, if I see it, I mean, it's a good system. Initially we estimated for 2.8 years, and if there is no pandemic, we would have been already recovered. That's what I would say. Yeah, that's where we.
Okay, thank you, Gopa. Thank you for your kind words. It was very interesting. We learned a lot about this project. Interesting also to see the symbiosis between the cooling towers and our solar panels actually allow the system to produce more. And when the property also used on the laundry side, the savings were even better. It was extremely interesting. Thank you, Gopa.
Thank you.
So now I would like to introduce Yasser, Director of Engineering of Radisson Blu Fujairah. Yasser, good afternoon.
Hi, good afternoon. Good afternoon.
Can you give us your insight and experience about all this project?
Yes, I will speak. Hi, everybody. Good afternoon. My name is Yasser Ahmed. I am the Director of Engineering of Radisson Blu Resort in Fujairah. Actually, I want to speak a little bit about when I met first time I met Hugo. It was in Radisson Blu Sharjah, and we did good survey there in the building to implement this system, thermodynamic solar system. And in Sharjah, it was gas boiler, and we made the survey and we make very good report, and the project keep in hold in Sharjah. That was before approximate 3 years ago. So after that, I moved to Radisson Fujairah, and definitely, you know, we are as engineering, our main target is to reduce the utility, to make saving, because we are as a department consuming money, not producing money in the hotel industry. So the main target for us to make saving, and definitely it will not affect the quality of the maintenance, our job in the hotels. So the main source which we can do is reduce the electricity or the utilities. So I contact Hugo again, and we make survey in Radisson Blu Fujairah. And in Radisson Blu Fujairah, actually the resort is so many buildings, as Hugo mentioned. It is around 9 buildings. Let's say the main buildings is building number 1, building 2, building 3, which is approximately 3 floors high. It's not high-rise building. It's coming horizontal, not vertical. And our hotel is 257 rooms plus suites, and we have small villas, which also separate buildings, all separate. So after we make the survey, what we have before as a hot water system, we had calorifiers, water heater, and this was very, very high consumption of the electricity. When I found this, immediately I contact Hugo and we make the survey, and we make good result in terms of saving. And immediately I discuss with the management and I convince them, and we go ahead with the project. So I want to say during the implementation of the project, there was a very really I'm 100% recommend Hugo and his team, because there was no disturbance to the guest during the implementation, during the installation of the system. We did everything ready, and the final connection we did it during night. So we didn't make the shutdown in the hot water system. The guest didn't affect. There is no guest complaint, and it was very nice installation for this system. After we finished the system, also I want to mention some important point: the after sales services, which is after sales services from Hugo and his team. Really, it's very nice and very good service, to be honest. In terms of saving, after we make the project, before we used to have approximately, as an average, 100,000 dirham per month, and after we make the project, it's big saving really. It is almost we consuming 10%, let's say, from 8 to 10%. So we saving approximately 90,000 dirham per month for this project. So it's big saving and it's good achievement, to be honest. And we have everything in the monitoring system, and everything is proved for as we make the survey. Even after we make the survey, we put from 80 to 85%, but after we implement the system, it's a saving coming higher than what we expect, which is very good. And also the good points is ROI. We expect this to be 1.5 years, let's say 1 year 6 months. And if we continue with this and definitely it would be good with this saving, I believe it will be 1 year and 4 months or 5 months as a maximum. So really, I recommend Energy for the hot water system, and thank you, Hugo, for this system. Thank you very much. If you have any question, I'm ready. Thank you, Hugo.
Thank you for your experience. I just wanted to comment that part of the installation in your property was done during COVID times, COVID lockdowns. It was a big challenge. Fortunately, everything went well, and everything was safe, and also the help of the Yasser and his team was very important for us to conclude the project without further delays. This is extremely important. Thank you, Yasser.
Thank you. Thank you.
So now I believe that Mohammed is not here at the moment. I read that he had an emergency engineering issue to solve. As you know, engineering can change from 1 hour to the other, so we have to be always available to solve it. So I'm going to speak in his behalf about the property. You know, Anantara is located in the Palm Jumeirah. Is a property that has villas, over water villas, beach villas, block villas of 4 and 8 apartments, and then multiple restaurants. So here the retrofit was different. It was also done during the COVID lockdown partially. So again, another big challenge. And here, you know, especially on the villa units even during COVID were with high demand. So it's always a big challenge because only when the villas are available we can actually go there. We also had to be very careful on the location for the panels because as you can see, this type design should not be affected. So we try our best to put the panels on the perfect locations and get approval for Mohammed and his team and the management team. This project was actually done in an ESCO model, in a share saves model, with Smart AE and Etihad ESCO. So we were one of the ECMs of the project, and the results are fantastic. We like all the other properties, we deliver what we committed, but also we keep a very good relation with the engineering team. We are now responsible for the maintenance of the project, and we are always ready to act and to help them. So the savings here were around 87%, and they are also being monitored. And the operation started. So this started in September 2019, and it was finalized in July 2020. So some of the properties are operating already for more than 1 year and a half, and everyone is quite happy. It's unfortunate that Mohammed is not here to tell us in his own words, which of course would be much better. So basically that's it. Now we have a Q&A session. So if anyone have any questions, we can address it.
Yes, Hugo, there are a couple of questions. If you look at the control panel, you'll be able to see the questions from there.
Okay, so let me try to see actually my control panel. Okay, let me try to. Okay, here they are. Just a second. So I have here a question. Let me see. So we have a question which is if we are based in Dubai and what would be the best location for them. So this technology is actually produced in Portugal, in Europe, and is deployed for more than 50 countries all over the world. So this, although GCC countries are a perfect location for our system because there is heat and radiance everywhere, and there is no negative temperatures. This system is used from the United States until Australia, New Zealand, so France, Germany. So it is in many countries all over the world. Here we are a standalone system, and every country that has similar conditions will be even better. So then we have a question regarding if we can integrate the system to the cloud platforms or BMS. Yes. So our system, we install gateways and meters and sensors, and then we upload it to the cloud, and any BMS system can pull it the data using Modbus or any open protocol like BACnet, whatever is available, we will provide. So let me see. I'm trying to read the questions, but actually the questions are so small that let me just try to. Just a second more. Okay, I think now it's better. So I have someone that is running catering in Sharjah, and yeah, we don't install only on hotels. Actually, for me, hospitality is hotels, but also restaurants. We have several restaurants using this solution. Of course, hotels they consume more hot water than restaurants per se, and therefore we address these points that can give a better example for our attendees. Also, it's we install in villas. There is another question regarding if it's feasible in individual housing units. Yes, we install it in villas throughout UAE, but of course it's required to have a centralized system. So some of the villas, they have individual water heaters, and therefore the change in the infrastructure will be more expensive than the system itself. It's possible, of course, but normally we retrofit or we supply for new units. But since 7 years ago, it's mandatory to have, for example, in Dubai, centralized hot water systems and hot water solutions for the, I mean, solar panels for hot water applications. So, and then I was going, maybe if there is any question for our guests, I will try to direct it, but let me see. So someone is asking if this solution is targeted for the Arabian Gulf region. So again, no, it's used in every part of the world, but here we have some benefits, which is our weather, and we can exponentiate that advantage. Then if can guests share what savings in terms of kilowatts or dirhams achieved. So this is for both guests, Gopa and Yasser. In terms of percentage, I think you addressed that already. And what was the carbon footprint reduction? So any one of you would like to mention? Gopa, I don't know if you want to answer this question.
What is the question? I didn't.
So what were your overall savings? It doesn't specify if it is per month or per year. What are your savings and your carbon footprint?
Okay, I'll just put it this way. The project we initially calculated for an ROA of 2.8, which is going to come down to less than 2 years. If not, the COVID is not on us. That's what I would say. Yeah. Due to COVID, occupancy is dropped, everything is dropped, so the production of the hot water system is definitely is very low. So then the recovery time is a bit of extended. Maybe it'll go back to 2.8 rather than going to be 2. That's what I would say.
COVID was a big challenge on operation with lower levels of occupancy, and of course, the less, let's say, demand of hot water, the bigger the return of investment. I think 2020 was a very challenging year for all hospitality. So we have cost comparison. I have here a question regarding cost comparison. Of course, in the end, there will be an email. If you can send me information, I will, and our team will answer you about this. The area required. So for the installation of the panels. So the area is variable. It's very flexible. Actually, we look at the space that we have available and we adjust. Both the property of Gopa Kumar and Yasser are good examples of that. We use the space available and we try to put it as clear and clean as possible. So regarding what is the heat pump capacity in electrical kilowatt? So see, our solution has the power input and the thermal power, right? The power input is actually how many kilowatts hour we are consuming to run the compressor. And for example, in a big unit that produces 15,000 liters of hot water per day is between 11 and 13 kilowatts hour, depending on the conditions with their storage. But the thermal power is 60 kilowatts. Again, it will vary during day or night and during winter and summer conditions. Okay, but that's the average. So just some more questions. So it says here, if I want to move forward with the implementation of such devices, what would be the next step? Again, it was the points we have discussed here about the infrastructure, what infrastructure is there, and how we can use it and how we can improve it, not infrastructure itself, but how we can replace the heat source and what are the benefits that come out of that. So that's the first point, to see what is the demand and what is the value proposition, and from that point on, if it makes sense technically and financially to move ahead with the next steps. The next step might be capex investment, might be a hybrid solution for financing, or to have a third-party company or an ESCO company to provide the share saving model, guaranteed saving model, because if we don't do anything, we are not helping the environment and we are not helping the property. Right now, the engineering team is extremely important to increase the revenue per room, because hospitality cannot raise prices. Actually, they are decreasing it. So the only way of really improving the revenue is by cutting costs. And right now, renewable energy is becoming stronger and stronger on that level, and is it's an opportunity actually. So on the warranty period and lifespan, so our panels have a 10-year direct replacement warranty, 5 years on the tanks and 2 years on the electrical components, and they have a lifespan overall of the system 25 to 30 years. And I think basically that's it. I've covered most of the questions here. So if I'm not mistaken, yeah. So so basically that's it. We have here our contacts. You can also contact Ahmed from CBC. I would like to thank our guests for their insights, for their availability, and Ahmed and his team for organizing this event. I hope it was an interesting event for everyone, and we are here to assist you or to clarify any additional points. Okay, thank you so much. Ahmed, you can take the floor.
Thank you very much, Hugo, and thanks everyone for joining us today, and thanks for the speakers. It was a very insightful webinar. So thanks again, and we'll share the material with all attendees later on. Thank you.
Thank you so much.
Thank you all. Thank you.
Thank you.
Have a nice day.
Thank you, Ahmed. Thank you. Bye.